everyone, this is Miss Salter, and this is a video on Molarity Example Problem C. I put the same intro in the top of this video, on the top of this document, so that you still have it here in this video as well. Molarity, number of moles of solute, that's the solid. In our examples, that's the solid. Per unit of solution, which is normally a liquid, and it is moles per liter. So you have to convert it to moles per liter to use the equation. It's one of the most common units to measure concentration of a solution. So molarity measures the concentration. So, like I said on the other video, if we're looking at this as the concentration of food coloring in water, a higher molarity would mean a brighter, kind of more solid color, a very like dark red or a dark blue in our liquid, whereas a lesser molarity or a less concentration would mean a lighter color. It's just most of the time you can't see the solid chemical dissolved in our liquid, and therefore we use something like molarity, this a measurement, to give us an idea of how much of something is in our solution. Now, it can be a gas in a liquid, like carbon dioxide in soda. It can be a gas in a gas. It can be, like we have here, a solid in a liquid. So we're just working with solids and liquids right now, mostly. Some of these chemicals we've worked with in class diluted into water. So our equation here is molarity equals the moles of solute over the liters of solvent. The solute is the smaller amount, the stuff that goes into the larger amount of stuff. And like I said, in our examples here, it's usually a solid into a liquid. We have some conversions here. We have 1,000 milliliters in a liter in case we need that. And we have some of our molar masses or our formula weights. Moles of a solute equals grams of a solute, and that all depends on the substance you're talking about. So it's different amount of grams per mole for each thing. So C says, how many grams of solute do you need to make 0.55 liters of a 1.2 molar solution of MgCl2? Okay, so this is the hardest example we have. This one we have to do a few steps to get where we want to go. So let me just go ahead and move this up. Come on, you can do it. Okay, so moles of solute you need to make 55 liters of molar solution. So when we look at this first, okay, so we were focusing first off last time on did we have the right units first. So we're going to check our units. So step 1 is going to be check your units. Now here I have a solvent, and I need that in liters. So actually let me put this properly here, and I'll fix the C while I'm at it. So we have check units. Do we have liters of solvent? And we were underlining that in blue. And then we have this one in green. So do we have our solvent in liters? Yes, we have our solvent in liters. Okay, but here's the other thing though. Do we have, now we have here, we are given our molarity. So we have M, and that's our molarity. So is our concentration in molarity? Yes, it is. So what are we looking for? We're looking for our grams of solute. Okay, so Our next step, we know we can find our moles of solute. Okay, so we can find our moles of solute. And then just what we'll have to do is have to change it into grams. So we have an extra step down further to try to work on that. So to get our grams of solute. So next step is going to be moving this so that it properly does what I want it to do. We're using our equation. So our equation is molarity, or concentration, equals moles of solute over liters of solvent. Now here's the thing. We are given our liters of solvent, and we are given our moles, our molarity, I should say, not moles, molarity of our concentration of our solution. We need to find our moles of solute. So we need to rearrange this, and a lot of times what you guys do, and I do this too, is we plug things in and then solve for it. So let's do that. So make sure I got, yep, black, okay. So we're going to have molarity, which is 1.2 molar equals moles of solute over 0.55 liters of solvent. So we're going to multiply by the 0.55 on both sides, so we get 1.2 times 0.5. Oh, that looks like a 6. That is not going to work. .55 equals moles of solute. So when we do that math, we get 0.66 moles of, what are we looking for? MgCl2. Okay. We know that that is our solute because it is a solution of MgCl2. A solution means the MgCl2 is dissolved in the water. So that's what we're looking for. So now we have a solute here, but it's asking for grams, of course. So now we have to change this into grams. So we have an extra step here that we need to worry about. So we have to do step 3. We need to convert our moles into grams of MgCl2. So to do that, we take our 0.66 moles of MgCl2 and we times that by 1 mole on the bottom, because we're starting with moles. We want to cancel that out. And our grams is 95.21 grams. Yep. And so that math comes out to be 839 grams. So we can round that to 60. I always do that. Forget to put it back on drawing. 62.84 grams of MgCl2. Boop, and that's our answer. Okay, so this one was a little bit complicated because we had to, because of what we needed to find here. So we were given the liters of solvent and the molarity. That looks like a V. No, that's not what I wanted to do. Stop that. There we go. Oh my goodness, we are just having such an issue right now. There we go. Okay, so we have grams of, how many grams of solute? So we're looking for solute. We're given our concentration in 1.2 moles. We have our 0.55 liters of solvent. Oh, look at that. It put that extra in there. Isn't that weird? Oh, good Lord. Now everything's getting discombobulated here. There we go. Done. Okay, so then we have 2 moles. We have our moles of solute over our solvent. And so we have to find our moles of solute. So we're multiplying, and then we get our answer in moles, but then we have to change it to grams. So I hope this was helpful, and have a good day.